Alright guys, welcome to your first video notes. Today we're going to talk about relations and functions. Remember, make sure that you're using the pause, rewind button. Those are huge when it's come to these video notes because that makes sure that you can really understand what we're talking about and then you're not missing writing it down. Now first we need to get some definitions. So under the definitions on your guided notes, first one is relation. A relation is a collection of ordered pairs. So it's really just a collection of x and y coordinates or inputs and outputs. So it's just really a collection of ordered pair x and y pairs. Okay, domain is your list of all your x or your inputs. So all your x values is your domain. All your range are your y values. So big thing here was relation is just pairs of x's and y's. A domain is all your x's. Your range is all your y's. Go ahead and pause it and make sure you write these down. Now there's three ways to display a relation. First one we're really used to is just ordered pairs. So go ahead and write these ordered pairs down. Alright, now when we're going to talk about the domain is your x values. So I'm just going to highlight or underline all of my x values. Okay, so I'm going to put a little squiggle bracket. That's what we do for domain, that little squiggle bracket. Okay, so I have -2, 0, 2, 5, and -2, but I already wrote it once, so I do not have to write it again because I don't need to rewrite all my x values. Just telling me that I have an x value of -2 is good enough. Now let's look at our ranges. Okay, I'm going to change colors. I'll use red. Our range are our y values. So our y values are 5, 3. You already used 3, so I don't need to write it again. -1 and 6. Okay, those are our domain and ranges for those values. Now another way we can write it is a mapping diagram. A mapping diagram just maps your domain to your range. So when I look at my domain and range, so my domain was -2, 0, 2, 5, and I already used 2, so I don't need to write it again. My range was 5, 3, 3, which I already used, -1, and 6. I got this from the same, because I'm doing the same exact relation that I did on the last slide, except now I'm going to show it in a different way. Okay, so mapping is just going to say what goes to what. So -2 went to 5, okay, 0 went to 3, 2 went to 3, 5 went to -1, and 2 also went to 6. Okay, that's a mapping diagram. Now, the third way that we can display a relation is by graphing. We've done this before. This goes way back to maybe 6th, 7th grade when you just graphed your points. So I'm just going to plot or graph those 5 points. So the first one was -2, 5. Okay, next one was 0, 3, over 0, up 3. Okay, next one was 2, 3. Next one was 5 over 5, -1, so right there, and 2, 6. So over 2, up 6, right there. Okay, so I just plotted those points. Make them a little bit darker so that you can see them. So I just plotted those 5 points. And that's it. I'm just showing my relation as a graph. Alright, so now I'm going to do domain and range on a continuous relation, which is a shape. So if I have like a circle or something that has a ton of points that make it up, like this circle has a ton of points. Okay, so what we're going to do, instead of having to list out all these points, because look, there's so many points in here, I can't really want to list them all out. So we're going to use interval notation. So for our domain, we're going to go from least to greatest. So domain is our x values. So I'm going to look at my x values. I'm going to go from least to greatest, or left to right. Okay, so I'm looking at my x values. So if I look, -1 is my lowest x value. So it's going to go from -1, which it includes -1 since it starts at -1, and it's going to go all the way to my highest x value, which is 5. And we're going to put brackets because it includes that number. It goes from -1 to 5. Okay, now we're going to do our range. Now if I look at my range, we're going to use our y values. So the lowest y value is right there. And if I look over on the y-axis, it's -8. So it's going to go from -8. And the highest y value is -2. All right, so my range goes from my domain goes from -1 to 5, and my range goes from -8 to -2. Now let's look at another example, right? So our x values, if I look at this, it's going on forever that way and forever that way. So I don't ever have a lowest or furthest to the left point for my range, okay? It goes on forever. So since it goes on forever, I'm going to put negative infinity. And we use a parenthesis because we don't know when negative infinity stops. And it goes on to the right forever, right? There's no stopping point going to the right, so it's going to go on to positive infinity. Okay. Now our range, if we look at our range is our lowest y value, so our lowest y value is right there at -2. And our highest y value, well, it doesn't ever stop going up, so it's going to go on to positive infinity. Okay. That -2 should be a bracket since it includes the number -2. Okay guys, so the new definition that we're going to talk about is a function. Well, a function is just a special type of relation. So we talked about a relation being x and y values. Okay, so a function is when each x is paired with only one y coordinate. So in other words, our x's don't repeat. Okay. So a side note, all functions are relations, but not all relations are functions. So you're going to see some examples here where it could be a function or it couldn't be a function. Okay, but the big thing here is that a function is when the x values only go to one y value, so your x values don't repeat. So a real life function is a vending machine. Okay, your domains are the buttons that you press, and the range are the candy, right? If I press one button, or if I press a certain combination of buttons, it's only going to give me one type of candy. A1 will only give me the A1 candy. It won't give me the Reese's and the Snickers. So that's a real life example of a function. So for these ones, I wanted to state the domain and range and then determine if it's a function. So our domain is 2, -1, 3, and 5. My range, or our y values, are 4, 0, 2, and I already used 4. Now, sometimes it's nice to write them in order from least to greatest. I won't count off if you don't, though. Okay. Now, is it a function? So, if I look, all my x values are only going to one y value. I don't have any x values that repeat. So yes, this is a function. Alright guys, so for this one, we've got to state the domain and range. So this is a mapping diagram that we're going to look at. So my domain for this mapping diagram is -6, 1, 2, and 3. That's a terrible squiggle bracket. Okay, but I'm going with it. So my range is -8, -5, and 7. Okay. Now, is it a function? So I have the 6 goes to -8, 1 goes to -8. That's okay that they both go to the same thing. Okay, but 2 goes to -5, and 2 also goes to 7. So that's where it's a no-no. That's why it's not a function, because my x value repeats. My x value goes to 2 other y values. So this would not be a function. I'll put not a function. Okay, for this graph, we're going to do the domain and range, and then is it a function? So if we look, okay, I wrote down the points on there because that's sometimes helpful. So this point was -2, 4. This was -1, 1. This one was 0, 0. This one right here was 1, 1. And this one right here was 2, 4. Okay, so now when I do my domain, I just need to list out my x values. Okay, so -2, -1, 0, 1, and 2. Okay, so you might want to pause it and write down those points because sometimes that's helpful. Some of you guys visually can see what your x values are just by looking at your points. Sometimes writing down the points is helpful though. So your range is your y values. Well, my lowest y is 0. Then I have 1 that happens twice, but I'm just going to write it once. And then 4 that happens twice. Okay, now is this a function? Now remember, we want to make sure that our x values don't repeat. Well, my x values didn't repeat, my y values did. That's okay. It still can be a function if your y values repeat. We're just looking at the x's. So I'm going to put yes, a function. All right, so to determine if a graph is a function, there's kind of a shortcut or a quick way to do it. It's called the vertical line test. Okay? The vertical line test is a line, up and down line, a vertical line, crosses a graph more than twice or more than once, so 2 or more times. Okay? It is not a function. It fails the vertical line test. Okay? So let's take a look at this next one. Okay? Vertical line test means that it's going to cross. If it crosses more than once, it's not a function. So I'm just going to draw a line right here. Okay? I could draw it over here if I wanted to. Now, do you notice how it crosses my graph twice? Okay? If it crosses more than once, it is not a function. It failed the vertical line test. Okay? So if it crosses more than once, it fails the vertical line test, means that it is not a function. Let's look at another example. Okay. Now, if I draw a vertical line, an up and down line, oh, it only crossed once. It only crosses once. It only crosses once. So right now, this thing is passing the vertical line test. Okay, I can't draw an up and down line where it crosses twice, so this is a function. Okay, since it passed the vertical line test, it is a function. That's kind of an easy way to think about it. If it passes it, it is a function. If it fails the vertical line test, it is not a function. All right, so your exit ticket. Think of some real-life examples of a relation, then justify whether or not the relation is a function or not. So one example that I can give you to give you kind of an example of one you might use, you need to come up with your own, but an example is iPad number to student per class. So each of you guys have your own iPads. Okay, so 1 would go to whoever has iPad 1 in this class. 2 would only go to the person that has iPad 2. So that relation would be a function. Okay? Go ahead and see if you can come up with one on your own. All right? And then go ahead and try the practice problems.